Assalamualaikum and greetings to beloved friends and lecturers. We are from DKM5B Group 14. My name is Siti Qurratul Aini binti Khalid. My metric number is F1065.
My name is Nurul Atikah binti Ariffin. My metric number is F1067.
We will presenting the case study of fire tube and water tube boiler. Introduction. Boiler also called as steam generator. It was designed to convert a liquid to vapor. In a conventional steam power plant, a boiler consists of a furnace in which fuel is burned, surface to transmit heat from the combustion product to the water, and a space where steam can form and collect. A conventional boiler has a furnace that burns a fossil fuel, or in some installations with fuel. Classification of boilers. Most conventional steam boilers are classified as fire tube boiler or water tube boiler. This is example of water tube boiler and fire tube boiler. Fire tube boiler, which is the fire or hot gas is present inside the tube and water surrounds the fire tubes. Horizontal return fire tube boiler, where it is most suitable for low capacity thermal power plant. The main construction feature of this boiler are one big size steam drum which lies horizontally open supporting structure. There are numbers of fire tubes come from furnace and also aligned horizontally inside the drum. When the drum is filled with water, these tubes are submerged in water. Diagram of fire tube boiler. A fire tube boiler has three main components, which is a double wall furnace, a horizontal cylindrical boiler barrel containing a large number of small fuel tubes, and a smoke stack with chimney for exhaust gases. Working principle of fire tube boiler. The fuel, normally coal, burn in the furnace and combustible gases move into the fire tubes, travel through these tubes from barrel to front of the boiler drum, and finally the gases come into the smokestack. The hot gases in the tubes underwater transfer heat to the water via the tube walls. Due to this heat energy, steam bubbles are created and come upon the water surface. As the amount of steam is increased in that closed drum, steam pressure inside the drum increases. This increases significantly the boiler temperature of the water, and hence rate of production of steam is reduced. In this way, a fire tube boiler controls its own pressure. In other words, this is a self-pressure controlled boiler.
Water tube boiler. A high-pressure water tube boiler is a type of boiler in which water circulates in tubes heated externally by the fire. The heated water or steam mixture rises into the steam drum, and in some service, the steam passes through tubes in the hot gas part to become superheated. Superheated steam is defined as steam that is heated above the boiling point at a given pressure. To increase economy of the boiler, exhaust gases are also used to preheat combustion air blown into burners and to warm the feed water supply in an economizer. A significant advantage of the water tube boiler is that there is less chance of a catastrophic failure, which there is not a large volume of water in the boiler, nor are there large mechanical elements subject to failure. A water tube boiler was patented by Blaikie of England in 1766 and was made by Delarue of France in 1780. Diagram of water tube boiler. The water runs in through water pipes, and the hot gases from furnace are passed over the outer surface of water pipes. The heat is transferred from the hot gases to the water in pipes and converted into steam. The hot gases will pass through the smokestack to release the hot gases. Working principle. The water is supplied into the steam type drum with the help of a water pump. When the fuel is burned, then hot gases which are produced by the fuel will replace heat by the water. Ergo, the water gets changed into steam. This happens because the water temperature increases, so the concentration will increase automatically. As additional, steam is generated in the boiler, then the force in the drum enhances and the water supply into the drum reduces, which tends for decreasing the flow of steam. In the same way, when the production rate of steam reduces the force in the water tube boiler, the water supply into the boiler, which tends to enhance the production rate. In this way, the water tube boiler controls the production of steam. Summary and conclusion. Water tube boilers are highly efficient machines by their design and produce superheated dry steam at very high pressures. They are the kind of boilers capable of feeding the processes of heavy industry and utility companies. However, the acquisition and installation costs are high. In the case of heavy industry that are custom-made on the installation site, which can be complicated and time-consuming. Furthermore, they are challenging to maintain. Thus, they require highly skilled personnel for operation and maintenance. Fire tube boilers, on the other hand, are the kind of boilers capable only for small-scale power plant because it has lower rate of steam production compared to water tube boiler. Therefore, there are less of risk explosion as less operating pressures. The proper startup of a boiler system is one step in the many required throughout the year to keep the boiler operating efficiently, be it the startup, shutdown and layup, or operating throughout the year. Each of these work together to keep a system problem-free for the long haul. Proper chemistry is very important, but so are the mechanical and operating procedure in the facilities that operate this kind of boiler. That's all from us. Thank you for lending us your ears.